Okay, so let's talk about a few other ways of tightening up this code. Okay, so first of all, let's get rid of our unused import. We'll do optimize imports. There it goes. All right. So a couple of things. Notice, in some senses, this sort of feels wasteful, right? We had to kind of write some empty methods. I mean, take a look. We had to include key typed. We had to include key released to actually be able to use that. If we didn't have these, by the way, so let me just show you this. All right, so if I take those out entirely, here's the situation we're in, right? So if we take a look, it says class turtle key listener must either be declared abstract or implement the methods, right? So let's take that first one, right? We had looked at the other ones of implementing the methods. What about creating the class, making the class abstract? Okay, so it seems like that might be a nice way of saving ourselves from having to do that extra work. So we come over here and then take a look. Turtle key listener is abstract, cannot be instantiated. You see, an abstract class, by definition, has methods that don't have an implementation, right? So for instance, this class has to have a method, key typed, that takes a key event, and also has to have a class, key released, that takes a key event, okay? But doesn't do anything. So the class is incomplete. And so an abstract class, you cannot create an instance of an abstract class. That's not allowed. Wouldn't make sense. But again, this kind of seems like it's going to get just be annoying every time we want to handle key events and so forth, having to do with this. So how do we get around it? Well, one alternative would be to do something like the following. So suppose I create a new class that's going to adapt the KeyListener interface. Okay, and here's what I mean by adapt it. So it's going to implement it like so. And then we'll implement all of the methods like so and leave every single one of them blank. Like so. Okay, now you might say, well, wait, what use is that class? Right? I mean, it implements KeyListener, but it doesn't do anything in particular for any of those particular functions. But see, here's the thing, because now I can do this. Now, I could also put that we implement the interface, but realistically, I don't have to do that. If you extend a class that implements an interface, then your class is also implementing that interface. So what that means is now I only have to have an implementation, an overriding, for the particular method that I'm interested in. Right? So let me just show that this still works. So here we are, hitting D, hitting A. That all works. That's good. What did we do here? Well, actually, before I sort of fully diagram that out, let me show you something else. It turns out this little adapter class that I wrote, it's such a useful idea that the developers of Java have done exactly this for you. Okay, so let me go ahead and delete this. And let's see, I'm just going to say delete. No, I'm not going to bother usage, search, and all of that. I'll just let everything die for right now. Okay, now, if we come back over to our documentation for KeyListener, if I scroll up, notice it says, okay, so it's an interface, all known implementing classes, right? And if we go through, we see there's this thing called KeyAdapter. And if we take a look at KeyAdapter, notice it implements the KeyListener interface, and if we take a look, it turns out that each of these methods, notice they are concrete methods, so that is they are implemented, but they just don't do anything. Okay? And so we have this adapter class built into Java so that we can then write the much more concise code like so. So we're going to extend KeyAdapter. We'll make sure to import that class. And then that means I don't need, I only need an implementation of the method that I'm actually interested in this case, keyPressed. Okay, so when we do that, notice there's D, there's A, etc. Since I'm probably going to upload this code, I'll actually leave these in but comment it out. Okay, and again, no longer need this, like so. Okay, so that's the point of the KeyAdapter class. The KeyAdapter class basically allows us to only need to override the particular method that we're interested in. And if you look at a number of the different other kinds of events in Java, you'll see this as well. When you have a listener that has a number of methods that need to be implemented, Java will oftentimes provide you with an adapter class for that particular listener as well, to make life a little bit easier. But let's go further. Okay, so this is fairly nice, it's reasonable code, it's respectable code, and so forth. But here's the thing, I mean, notice, we kind of had to write a whole bunch of stuff. We had to create a whole brand new file. We had to then we had to do our stuff with the NOSA relationship for turtle and all that. Oh, sorry, let me actually back up here. So now to complete our diagram here, let me just kind of move some stuff around here. Yeah, that's going to be, there we are. All right, so we'll do this kind of zigzagging here. Also, actually, since the changes that we've made in the diagram really look more like that, we're not even really using animated turtle. But now what we have is this. Okay, so we have another class, right? And that class, as we saw, so we don't need a stereotype for this. We don't need that. We don't actually care about whatever properties it may or may not have. We will get rid of these. And really the only thing we care about is the fact that it does in fact already have implemented inside there these. The other thing, actually, I'm surprised it didn't seem to do this for us, and so I should probably put that in. Is that these should be italicized here because they are in fact abstract, right? And that's what that means. Okay, so here's basically the setup that we have, and so in this case, Turtle KeyListener is a type of KeyAdapter, and then KeyAdapter acts as a key listener. Okay, so that is that is the implementation there. Okay, so that's what that looks like. That's basically what we have. Now let's take it further. Okay, so it turns out that I can kind of get rid of a bunch of this stuff. Okay, in fact, when they came up with Swing, they actually added some new functionality into Java to be able to do what I'm showing you now. So what I'm going to show you now is something called an inner class. And in particular, I'm going to show you an anonymous inner class. Now, I'm kind of skipping one step. I could just create a class nested inside main, a nested name class. I'm going to skip that and just go on to show you kind of the full Monty of this, namely the anonymous inner class. So here's roughly how that looks. Okay, so I'm going to comment that out altogether. I'm going to do this just for clarity's sake in kind of two steps. That is, I'll create something. I'll say, okay, we have a key listener, call it KL, and that's equal to, and now watch. So I'm going to say it's going to be a new key adapter. And I want the key pressed event, like so. And I'll put a semicolon right there. Okay. What this here is a class that doesn't have a name. Say that again. It's a class that doesn't have a name. It is an anonymous class. But what we do know about this class is that it extends KeyAdapter. And here's the implementation, right? So our implementation is just going to be T. Notice I can refer to the variable out here, actually want the code that's sort of like this. Okay. Let's see. So I'm just going to, since we've done a copy and replace, I can do a quick refactor here and do a rename and call that T. Right? Why am I calling it T? Because the name of the variable here is T. This T is that T. Okay. Formally, this is referred to as a closure. That is, this anonymous class has closed over that occurrence because T is not declared inside the context of this class. Okay, the other thing is this right here. Let's see. I want to create a static constant. It's actually not where I want it. So let me just. I did it. Might have just seen the option. Create constant, there we are. And I want it in main, yeah. And I don't want it a double, we want it an int, and we're gonna make it 3. Okay, so there it is. We have our static constant like before, and now we have, so what we have is we have our class right here that doesn't have a name, and we immediately create a new instance of it. So it's a class that is sort of a throwaway. It's a one-time use class. Okay, and so down here, what we will do is to say, instead of that, we will say, just use KL. Okay, and so there's the D key, there's the A key, and all of that is working without making use of the Turtle KeyListener class itself. All right, so this notion, this notation of creating an anonymous inner class was introduced specifically for this kind of idea. All right. So you can see kind of how that works and so forth. Now, one other tip, and referring back to kind of some of the other videos that I showed, especially the video on using the streams API and dealing with Java lambdas. If you have an interface that only has a single method that you need to implement, then you can in fact use a lambda to implement that. So an example of that, a good example of that, one that's actually really common for a lot of things in swing programming, is Actionlistener. Okay, so if we take a look at Actionlistener, notice there's only one method, action perform, that takes an action event. Okay, so I could create a separate class that implements the Actionlistener interface. I could use an anonymous inner class for implementing this interface, or I could just create a lambda expression. I could provide a lambda expression anywhere where such a thing was required. All right, so that gives you kind of a good idea of that. So I'm going to stop the video here, and again, we're going to pick up in the next video where we're going to see another way of dealing with key events in terms of swing.